A standard solar system mainly consists of solar modules and inverters. When solar modules are exposed to sunlight, they convert light energy into direct current, DC, while inverters convert the DC into alternating current, AC, and feed it into the power grid. The solar inverter, as the brain of the solar system, determines the power generation efficiency and operational stability of the system. In current solar systems, based on the resolution of system control, there are mainly three types of inverter technology solutions: first-generation centralized inverter technology, second-generation string inverter technology, and third-generation module-level inverter technology. Generally, distributed solar power stations use second- and third-generation inverters. Although second-generation string inverter technology is currently the most widely used in distributed solar systems, it has many drawbacks. In such systems, solar modules are connected in series. However, the power curve of each module differs from each other due to manufacturing tolerance, installation differences, shading areas, and many other factors. This is called a performance mismatch between modules. This mismatch results in a bucket effect in the string, which reduces the overall power output of the entire system. Besides, the design of these systems requires that all strings with the same length, using the same type of modules, be positioned at the same angle towards the sun. However, in the real world, the roof condition would not be perfect. The strict design rules of the string inverter system will lead to a waste of roof space or non-functional modules in the system. Furthermore, the DC cables connecting the solar modules and strings carry a high voltage of several hundred volts during power generation. Second-generation inverters are unable to effectively shut down the high DC voltage of the modules in case of emergency, leaving serious safety risks to system users and maintenance workers. Second-generation systems also cannot monitor the power output, temperature, and other parameters of individual modules. Therefore, module-level failures cannot be remotely diagnosed in such a system. In recent years, the microinverter system, a technology belonging to the third-generation module-level inverter technology, has received wider attention. This approach scales down the functionality of traditional string inverters to individual modules. By controlling each module individually, the microinverter can address some of the issues present in second-generation inverter systems. However, microinverters also have their inherent weaknesses. Such systems require each module to be equipped with an independent and fully functional inverter, leading to a significantly higher upfront system cost compared to second-generation inverter systems. Taking into account the pros and cons of the aforementioned inverter technologies, Advanced Sol has developed a third-generation smart micro-string inverter technology based on the following criteria. 1. Ensuring safety. Module-level rapid shutdown to prevent extreme solar accidents. 2. Increasing power output. The system achieves 10% more power generation, with the potential for over 30% increase in some extreme conditions. 3. Reducing operations and maintenance cost. Module-level performance monitoring allows a 50% reduction in O&M cost. 4. More flexible system design. Regardless of shading, orientation, or other roof conditions leading to module mismatch, allows more flexible system design and maximum rooftop utilization. 5. Cost-competitive solution. 6. Wide application range, suitable for residential, commercial, and even utility-scale solar systems. In Advanced Sol micro-string inverter system, the inverter functionality is achieved by two products: the module-level microcontroller, referred to as microcontroller, and the smart string controller, referred to as the string controller. The microcontroller is located on each module, turning the modules into intelligent modules. The microcontroller enables module-level data tracking and real-time adjustment of current and voltage to the optimal working point of each module. The string controller is similar in appearance to the second-generation inverter, but only performs DC to AC inversion, grid connection, and data processing functions. The Smart Microstring Inverter system from AdvanSol has two additional features. 1. AdvanSol's A-Cloud Smart Energy Platform can be accessed through any computer or handheld device. 2. Enhanced safety mechanism. The cables, connectors, and connection methods used for the installation are the same as the second-generation string inverter system. However, compared to a second-generation system, AdvanSol's Smart Microstring Inverter system allows the installation of more modules, combining long and short strings and installation modules on different orientations of rooftops. Based on the A-Cloud Smart Energy Platform, AdvanSol provides a comprehensive set of data at the system level, string level, and module level. This data can be used for rapid fault detection, real-time alerts, and complex system maintenance analysis, effectively reducing the system's operating and maintenance costs. Furthermore, we have introduced module-level safety mechanisms to ensure the safety of the station users, installation workers, and firefighting personnel. In AdvanSol Smart Microstring Inverter system, when the AC power is disconnected, the DC high voltage of the strings is automatically reduced to a safe voltage level. By using the AdvanSol Smart Microstring Inverter system and optimizing the power generation of each module, investors and system owners can achieve higher returns over the system's lifetime while reducing unforeseen failure variables. Additionally, remote operation and maintenance can be carried out over the long term, minimizing the need for on-site troubleshooting. By increasing revenue and reducing operating costs, the AdvanSol Microstring Inverter system brings greater value to EPCs, operation and maintenance providers, and system owners. AdvanSol, it's so powerful.